In this lesson, we're looking at multi-step equations, special cases, and we have no solution versus all real numbers. And so we have um, equations where sometimes variables will cancel out. And if that happens, we want to look at the number statement that is left. If you get a true statement like 5 equals 5, that is a true statement. 5 does equal 5. So my answer is all real numbers or infinite solutions, meaning any number we plug back into that equation will work. Okay, so if you're used to doing equations, to check your work, you plug it back in, right? So any answer would work if your variables cancel out and you get a true statement. And if you get a false statement like 6 equals 13 or negative 13, that can never happen. 6 will never equal negative 13. So if your variables cancel out, then your answer is no solution. So meaning the answer to that problem is that there is no answer, okay? So we're going to try some problems together. Then I'm going to try some on your own. Then you're going to try some on your own, all right? So let's go ahead and get started. So let's take a look at special case number 1. So let's take a look at the problem. We want to solve it like we do any other multi-step equation. If we have parentheses, we want to distribute first. In this case, we don't see any parentheses. But then next we want to look and see if we have like terms on the same side. And we do. Over here I have 8x minus 9x. 8 minus 9 is a negative 1. So that's going to be negative 1x. And we don't put negative 1 or 1 in front of the x. It's just standard. It's just going to be negative x. I'm going to bring down that plus 6 equals. Can you spot the like terms on the other side? Hopefully you see that you have 2 minus 15 or 2 plus negative 15. So the first thing I'm going to do is bring down that negative x, okay, because I have that minus in front. But 2 minus 15 is a negative 13. Or you can read it as 2 plus negative 15. That is the same thing. So make sure you're paying attention to your signs. All right. Now I want to combine my variables. So I always want to do that first if I have variables on the opposite side. So I have a negative x here. I want to add x to both sides. This cancels out. Negative x plus x cancels. And negative x plus x cancels. So I'm left with 6 equals negative 13. And so this is not a true statement. So my answer is no solution. Okay, so my answer is that there is no answer. Why? The variable terms cancel out. The statement is a false statement. This means no value of x will make the original equation true. So the answer to this problem is that there is no answer. So my answer, you will simply put no solution. Right here, this is just to work a little neater. Sometimes my handwriting can get a little messy, but this is just to work here a little neater, all right? We're going to keep it moving. Let's look at special case number 2. Now let's take a look at special case number 2 here. And we want to see if we have like terms on the same side, and we do. X minus 3x, that is negative 2x. Bring down that minus 4. And I cannot emphasize enough to look at your signs because that will throw off your entire problem. So please pay attention to your signs, okay? On the right-hand side, I have negative 3 minus 1. Negative 3 minus 1 is a negative 4 minus 2. And actually, if you look at the problem right here, we can see that the answer is going to be all real numbers or infinitely many solutions because we have the same terms. And so if you could see that, I got a negative 2x and a negative 2x. I have a negative 4 and a negative 4. If you can identify that before you combine like terms, you can stop and say the answer is all real numbers. But if you don't see that, that is okay. We're going to combine. So combine our variables. So that's a negative 2x. So I'm going to add 2x to both sides. Cancels out. I'm left with -4 equals -4. And what do you know? That is a true statement, right? So my answer is all real numbers because both sides, so let's look at our y here, both sides simplify to the same expression. After the variables cancel out, it's a true statement. So this means that any x value you plug in will make the equation true. So again, all real numbers, that means you get a true statement. No solution means you get a false statement once your variables cancel out. All right. So now next, let's have you try some problems on your own. Well, again, this is just to work a little neater. Now you're going to try some problems on your own. So let's get to those two problems, okay? I forgot I have this slide here to remember to show you how to solve or how to use the final statement. So if it is true, like 0, 0 or 5, 5, the equation is true for all values. Again, the answer is all real numbers, or infinitely many solutions is another name for that, okay? If it's a false statement, like 0 equals 7, the equation is never true. Your answer is no solution, all right? So now let's get to those two problems. I have two problems right here that I would like for you to try on your own. For practice 1, that is 2 plus 3d minus 1/2. So if you rewrite it, if you're writing it down, right, that's 1/2. Okay, so go ahead and try these two problems on your own. All right, so for both of them, you should have gotten no solution. So hopefully you weren't thrown off by thinking, okay, one has to be true and one has to be false. That's not always the case. So both of these are no solution. So that fraction could have thrown you off. I threw that in there to kind of, make it a little tough and, see if you could do it. But you have your work right here. A 2 plus, not 2. 2 minus 1/2 is 1.5. Okay, if you change it to a decimal, that's fine. But that is not going to check out because these 3Ds are going to cancel out, right? So they're both no solution. Hopefully you got both of them correct. All right. We've reached the end of this lesson, and I would like to thank you for learning with me.